I'm on a really quick another video. Anybody who's, well, not at school, it's circle theorems. I've done one or two, but this I'm going to try to cover all of circle theorems from BGP Edexcel book on something like 220, page 220, page, no, it's not 220. On the current copy I've got, I'm on page 221. It's circle theorems. So let's crash from the top to the bottom. Alright, so what I'm going to do is I'm going to print screen and drop it onto my bit paper so you can actually see what I'm doing. Alright, so let's just recap. One of the really common mistakes when you haven't done this for ages is getting your names for all different things. So let's start from the basic. Circle, circumference. It's not really a circle, it's been squished, but we'll live with that. Now, if I draw a line from the middle out, and it must be exactly in the middle, this is called a radius. And then we have, if you double it, and it's really nice because they'll do naughty things like this, so I might as well start doing naughty things. Diameter. So we have a line that looks like a diameter. It isn't a diameter because it doesn't go through the middle. And this is called a chord. The other one where we have part of the circumference, let's change colour, let's do it my favourite colour, baby pink. So you've got part of the circumference that's called an arc, or arc length, or yeah. The next one, I'm going to kind of, you probably won't see like this, they like to throw it in with a radius. Do you know what? Why not? Why not? Let's do both. Pink, nice. Now there's my tangent. Tangent, which you'll rarely see your tangent alone. You'll see your tangent attached to your radius. This is a right angle here and a right angle there, and that will do me. This goes through the middle. So second circle theorem, we're going to consider this one my first circle theorem and this one the second circle theorem. If you draw a triangle off a diameter, that's a diameter there, it will always make a right angle triangle. But you see, they're not nice like that. They're not going to give you something so simple. They are going to be really little annoying children, and they're going to go, ooh, looky, I'm going to give you another triangle underneath so you think it's a quadrilateral. And that's 90 degrees there as well. Anyway, so there's the first four questions. Nice and easy. So what I'm going to do is I'm just going to move up there. So I've got those first four questions. They're in your textbook just because you're going to be a lazy. Okay, so you got 8 questions. Check your answers at the back of your textbook. If you still don't know what you're doing, drop a comment. Send an email if you're one of my kids. If you're not one of my kids, you shouldn't be watching this unless you bought the book. Now the next rule is no matter where you draw your radius, right, they're always the same length. If your radius is the same length, worst case scenario, if I draw a triangle, they're all isosceles. And I say worst because that means you've got to work out the little angles at the bottom. Now first things, right, as you're doing this, you'll be told, ooh, they're all isosceles. But they're upside down and sometimes at an angle and all sorts of stuff from what your teacher doesn't tell you. Well, not all teachers, we do. Us old folk do. The young ones are just, well, far too young. This angle here, let's call it A, is the same as this angle here. It's these two angles that are the same. And one common mistake, and let's do it in another colour, let's do it in a dull colour, mistake should be dull. Lime green. Buster Lime! I remember that. What did I watch? Oh yeah, Home. Buster Lime. So the most common mistake is, oh look, I think that angle's the same as that angle. No it's not, unless. Unless, and since we're doing an unless, let's do it in baby pink. I like baby pink. This side is the same as that side, is the same as that side, and it does happen. If that's the case, this is 60. Okay, so then we come to our next kind of circle theorem, and anyway, so if I've got diameter, I've got a chord, I know it's a chord, it's not going through the centre. Oh, that's disgusting. Try and get that straight, hold on. So if this is the same side length as that, if these two are the same length as each other, 90 degrees. So there you go, all 90 degrees. Anyway, I'm going to leave that there. Alright, so the next circle theorem. If I have 2 points, and we'll call these points A and B, if I start any line off here, then the first thing to realise is whatever the angle is, let's say 30, this looks more like 60, 70, 80, and that's 30. Right, so that's the first thing to realise. Now I'm going to, so the angle over here, let's call it C, is the same as the angle over here, D. There should be capital letters, but will live. You'll notice something. If I take all of this, let's rotate it. Ooh, upside down. Well, the rule's still the same. So, if all of a sudden, what I mean by the rules are the same, if we start from this point here and this point here, let's change colours. Let's go to that nice little blue that was working really well with the baby pink. If I've got these 2 points, that would mean that this angle here, now that does look like 30. Let's call it 30. Would be the same as that angle there. Not that they're all, oh my god, I shouldn't have done that. Let's make it 31. So if this is 31, then this is 31. Because otherwise you think all the angles are the same, but they're not. It's just these ones here on the ends, where you've subtended out. Anyway, let's stay on this page. That was quite a nice, easy one. Let's just drop the questions onto there. Yeah, let's just pop back to there. You see, the ton of questions. They're on page 2. What did I say? 223. Next circle theorem. I've got a circle. I've got a four-sided shape, more commonly called a cyclic quadrilateral. A cyclic means in round, round, round. Quadrilateral means four-sided. Now this is only true if for a cyclic quadrilateral. Well, we don't have to pay attention. If you have a four-sided shape inside the quadrilateral, let's call it angle A, angle B. Angle A, our B will equal 180 degrees. So for example, opposite angles always add up 180 degrees. If that's 80, that's 100. So have a go at those questions. Next circle theorem. I'll explain it again. These two are radii, really long tangent. Two tangents that start from the same point. Baby pig time! 90 degrees, 90 degrees. If you've got a tangent touching a radius, it's at 90 degrees. If they start from the same point, these two are the same length. So how can I mess with you guys? First of all, I can drop a line through there. You think, ooh, true right angle triangles. I can then go 3. I can go, oh, do you know what? Let's make that 3. Let's make that 9. And how do you work out this? Well, the truth is, first of all, it's a right angle triangle, so it's Pythagoras. And the second really, really, really annoying thing is, you think that this is the hypotenuse. It's not. It's this. This is longer. So I'm going to throw 3 questions on there. So have a go at these. There are a few more, but they just get more fun later on. Next circle theorem, page 226. Oh, this is the one. Oh, I like this one. It's really easy. What you have is a tangent. And then what they go and do is, instead of give you a really nice radius here, they give you a triangle. If this is 75, then this one's 75. If this one's 60, if that one's 60, that one's 60. And you go, is that it? Yeah, that's it. That is the same as that. They give you lots of questions, and the questions are absolutely horrific. Now, I've kind of chopped some of this off, and I hope you get all these questions. We're on page 226. Finish them out of the book. Okay, so the next circle theorem. What we have is a chord crossing another chord, and we're going to label they're going to be black. So we're going to call this P, Q, R, S, T. The rule's really simple. SQ times QT is equal to PQ times QR. Unless they go, do you know what? I got this, I got that. These are not tangents. First things first, these are not tangents. Secondly, from P, Q, R, S, T. PQ times, and it is not QR, PQ times PR. So this distance here, whoops, times this distance there is equal to ST times SR. Now, you've got 2 things. The only way to deal with that is to really practice them, really get them into your head. And then after you've given it a decent amount of welly, go on to the really tough exam questions, because they're not about maths. And my students turn around and say, well, what do you mean maths isn't about maths? Maths is not about maths, it's about problem solving. And if all you can do is maths, you're a 6 or a 7. If you can problem solve, well, then you get up to 8s and 9s. Right, you little darlings, that's your questions. You're stuck, leave a comment, tell me, all that kind of stuff. I better now get helping my wife.